Problem 124, Quantum Mechanics. The question is, the infinite square well potential of a particle in a box of size A is modified as shown in figure below. Assume delta much less than A. The energy of the ground state compared to the ground state energy before the perturbation was added. In this problem, we have to find out the correction in ground state energy due to this perturbation. So first, let us find out the first order correction in ground state energy, that is psi10 h dash psi10. For infinite square well potential, we know that psi10 is root of 2 by a sine pi x by a. Therefore, E11, that is integral 0 to delta root of 2 by a sine pi x by a. Here the perturbation is minus E in this region. Then root of 2 by a sine pi x by a dx. Plus, for the second region, the limit is a minus delta to delta. Then again root of 2 by a sine pi x by a. The perturbation is plus E. In the region a minus delta to a, the perturbation is plus E. Then root of 2 by a sine pi x by a dx. Now this is equal to minus 2e by a integral 0 to delta sine square pi x by a dx plus 2e by a in integral a minus delta to delta sine square pi x by a dx. Now we have sine square pi x by a is equal to 1 minus cos 2 pi x by a divided by 2. Therefore, E11 is equal to minus 2e by a integral 0 to delta 1 minus cos 2 pi x by a divided by 2 dx plus 2e by a integral a minus delta to delta 1 minus cos 2 pi x by a divided by 2 dx. Now this is equal to minus e by a integral 0 to delta 1 minus cos 2 pi x by a dx plus e by a integral a minus delta to delta 1 minus cos 2 pi x by a dx. Now this is equal to minus e by a, then x minus a by 2 pi sine 2 pi x by a. The limit of integration is from 0 to delta plus e by a, then x minus a by 2 pi sine 2 pi x by a. The limit of integration is from a minus delta to delta. Now this is approximately equal to minus e by a delta plus e by a into delta minus a minus delta. And this is equal to 0. Here we have used the approximation that delta is very small. Therefore, sine 2 pi x by a is approximately equal to 0. Delta is very small and it is closer to 0. Therefore, sine 2 pi x by a is approximately equal to 0. Hence, the first order correction in ground state energy is 0 due to this perturbation. Now let us find out what is the second order correction in ground state energy, that is E12. Now the general formula is sum over 1 not equal to m, then psi m0 h dash psi10 whole square divided by E10 minus em0. Now what is E10? E10 is the unperturbed ground state energy, that is pi square h bar square by 2 ma square. E20 is the first excited state energy, that is 4 pi square h bar square by 2 ma square. E30 is the second excited state energy, that is 9 pi square h bar square by 2 ma square. Now let us expand E12, that is equal to psi20 h dash psi10 whole square divided by E10 minus E20 plus the modulus psi30 h dash psi10 whole square divided by E10 minus E30 plus etc. Now let us analyze the terms. We can see that the modulus of psi 20 h dash psi 10, the modulus of psi 20 h dash psi 10 whole square, that is proportional to E square because the perturbation term contains epsilon. Similarly, psi 30 h dash psi 10 whole square, which is also proportional to E square. Now let us consider the difference in energy, E10 minus E20, which is negative. Then E10 minus E30 is also negative. Therefore, we can say that the second order correction in ground state energy E12 is proportional to minus E square. That is, it decreases by a term of order e raised to minus 2. Therefore, option D is correct.